Welcome to another video. Today we're just going to be doing an overview of integration by parts, and we're going to do this by solving a differential equation that uses method of integrating factor. We can see right away that we don't have standard form yet. In order to do that, we need to get a coefficient of 1 in this leading spot. And so I'm going to do that by just dividing through the entire equation by x. Now we should recognize something here. We have an equation in the form, but okay, this should immediately tell you integrating factor. We'll use this integrating factor to then multiply through our current version of the equation, which is this. Now we can see that this is actually the result of a product rule. So what I'm going to do is I'm going to write the left-hand side of the equation as if it were in terms of a derivative of a product of two functions. And those two functions are just x to the negative 4 and y. And if you look at the left-hand side of the equation, if you were to take this derivative, you would get exactly this applying the product rule. And I can just keep this side on the right the same. How do we get rid of this derivative operator? Well, we can just integrate both sides of this with respect to x. And on the left-hand side, the integral operator cancels the derivative operator, and you're just left with simply the product of the two functions, and then you have this integral. We can do the tabular method by taking the derivatives of the algebraic function and then taking the integrals of the exponential function successively. So I'll make a row for the x derivatives, and then I'll make a row for the e to the x integrals. And then we just do the diagonal multiplication with alternating signs, and we end up with and then plus some constant of integration. Since we're doing an indefinite integral, there's no bounds given. Now, just to solve for y, we can just divide through by this x to the negative 4. And this will give us our solution to the differential equation of function y in terms of x. And if we just do our arithmetic here, and this is the solution to our differential equation. So I hope this was a good review. If you have any questions, leave them in the comments. If there's anything you'd like me to cover in the future, also request that in the comments. I would be happy to oblige. Thank you for viewing. Have a wonderful day.